Hello everyone, welcome to my channel. In last video I show how to connect the microphone and speaker to the development board of nRF52, and today I think it's time for me to create a PCB because I don't want these wires to be around, and it actually affects the stability. Also I try to evaluate the real performance of the microphones and speakers, and when making the own PCB, we can mount the microphone and speaker into the board directly. So yeah, that's will be better. And to make a PCB, I came across two tools. So one is the KitKat EDA, and this one is the open source one, and it's very popular, and it has most functionality to lay out the simple board, and it also has the 3D viewer, so which is also quite handy. It also comes with a library, so there's also a lot of library in place, so you can use. This is very good. And the other one then is also the ECADA. This is one is more commercial, and you can use freely for personal use, and it also integrates a lot of components, and then it supports also the 3D view as well, and so which is also very good. I choose this one for this time for PCB layout, and I've designed it my circuit. This is also a very simple circuit, just with some speaker and also with the microphone connected, and with some these standard functionalities, connectors, debugger, for example. Actually, one thing I want to say is, okay, if you want to put in some components, you can actually go to here, libraries, and then you can put in search, and then after that it will just search in his library and see how what was the possible search result, and then you can actually get the price if it's in stock. Here for example, like this one, you can have $6.45, and yeah, then you kind of get an idea how much you will spend on the component wise for this board. And of course, when you are happy with the schematic, then you can actually go to update PCB. For the first time, you probably need to do the convert schematic to PCB. And in here you can do the update PCB, and then you can actually say check the nets, and then if everything goes okay, then it will go into this mode, the PCB layout the mode, and then in here you can lay out the PCB as you like. And here I have do my layout already, and then it's usually like back and forth for quite some time, and then after that you can also check on the 3D view, because this component, they come with the 3D model, so you actually get an idea on how does it look like for your PCB when you're trying to after you have laid out the system. So yeah, it's something like that, which is also quite handy. And when you are, of course, happy with the PCB, then you can go for manufacturing. So in here you have this fabrication, and okay, I will not do this check anymore. So okay, here then you will see this in this page, and here you can actually generate the Gerber file. I already have one, but we can actually replace. And with that, actually you then can use this Gerber file in any producer, like PCB manufacturer. And after that, you can actually say yeah, because they integrate, and you can order here, but you can basically order anywhere. And in here you have like selection on different type of PCB, and for example, if you select 4-layer, and you can do this upload of the Gerber file. Initially it says okay, like $2, but of course when you select the different options here, you will get a different price. For example, like by default it's $2, and then if you say okay, I want to control maybe impedance, you can actually do that. You can also select the thickness of the PCB, and then if you do, for example, like how many design in here, then you see that the price will be different. In my case, I just keep one design at a time. After that, you can also need to fill in the layer of the PCB, and then usually it's a top layer, bottom layer, and then you have inner 1 and inner 2 here. And after that, yeah, you can also select, for example, left 3. So yeah, you will have the price increase a little bit. But one thing to be noted is that in here, when you look at the capability of the PCB manufacturer, they usually have different capability. In this manufacturer, actually say it's able to produce 0.2, 0.4 hole. But then the thing is, if you select for 0.2, 0.4, then you will see the price jumping a lot. So therefore, before you design, you need to make sure that yeah, here. So before you design, you need to make sure you have proper size. You can maybe check the capability page of the manufacturer. So if I say here, no, not this one. So I just say, if we go to the PCB manufacturer's page, usually they have this capability. So, and for example, the hole size here, you can see that it's 0.2 to 6.3. This is the hole size. But if you look at here, minimum VR, that was the hole from, for example, different between different layer. If you want to route the line from top layer to bottom layer, then you need to have this VR. And then the VR actually come with the hole and also the diameter. So it says 0.4 here, but if you go to here, if you select 0.4, then your price is like jumping a lot. So yeah, just when you design, just make sure that if you can, then keep maybe the appropriate size, so that you limit your the, how do you say, your cost. And basically after those selection, then you can say, okay, I want to produce. You can also order the assembly service, basically, but then you need to specify the parts. From my experience, you can get some parts, but maybe some of parts you cannot get it. You need to only order from their side, and some PCB manufacturer will support you order your own components and provide to them. But I think this manufacturer doesn't support that. Yeah. Okay. So, and the other thing is, if you don't want to ask them to assemble, then you can also get the stencil. So basically you will get like a plate of metal plate, and it's a laser cut, and then you can use solder paste, and then after that, you can actually you can use those soldering station or BGA station in order to solder the chip into the board. So yeah, it will also add you some cost here if you see it. Right. Okay. So after that, basically, you can then say save to cart, and then you can log in and then order and pay, and then you can wait for the PCB to arrive. So based on the previous experience, this is actually pretty fast. I get it on a little bit more than 1 week. I also sent out my design, so I'm quite excited to see how does that work. Yeah, I also show a little bit layout, working on the PCB time-lapse video in here, so that you can get an idea on how does it look like to work with this PCB. So okay, I hope this video also provides some information to you, and yeah, if you have any questions, leave the comment. Thank you, and we'll see you next time.